Hello there, friends of chemistry. We're doing module 3 test, and I'm starting here with question number 8. A chemist decomposes 100.0 grams excuse me, 100.1 grams of a substance into 12.1 grams of carbon and 40.0 grams of magnesium. The only other product of the decomposition was oxygen, but the gas escaped from the chemist's experimental setup. What was the mass of the oxygen gas that escaped? So for this, we're going to apply the law of mass conservation. So we're going to say this plus this plus this will equal 100.1. Right? So we're going to take these two numbers, add them up, subtract them from this, and we'll find that, because that's the way math works. So we say 12.1 plus 40.0 is 52.1 grams. And with our rules of precision for adding, that's the way we're going to express it. Whoops, subtract. So we get 48.0 grams of oxygen must have escaped. It's actually going to be O2, but we'll learn about that later. So 48.0 grams of oxygen is the correct answer for number 8. Number 9. In an experiment to determine how to make sulfur trioxide, okay, and that's going to be sulfur trioxide, a chemist combines 32.0 grams of sulfur with 50.0 grams of oxygen. She finds that she made 80.0 grams of sulfur trioxide. There we go, number 3. And had 2.0 grams of leftover oxygen. Okay. How did the chemist make 100.0 grams of sulfur trioxide so that she has no leftovers? All right. So if there are 2 grams of oxygen left over, that means that 48.0 grams of oxygen were used. And that's 48 plus 32 equals 80. So that should be correct. Okay. So if she wants to make 100, let's see what that would be. 80 times some number is going to give me 100. So that number is going to be 80 going into 100. And 1.25. So the factor by which we multiply our ingredients to get 100 grams of this will be 1.25. Now, we're not going to multiply 50 because that's not how much she used. She used 48 grams of oxygen. So we're going to multiply that by 1.25. So I'm going to say 1.25 times 48. It's easier math. 5 times 8 is 40, carry the 4. 8 times 2 is 16 plus 4. Down 0, carry the 2. 8 times 1 is 8 plus 2 is 10. 4 times 5 is 0, is 20. Write down the 0, carry the 2. 4 times 2 is 8 plus 2 is 10. 1, 2, 1, 2. So for the oxygen, you're going to, so now we need to look at significant digits. It's 48.0 grams of oxygen. So this is going to be 60.0 because it's 3 significant digits. So we have 60.0 grams of oxygen. And also multiply the amount of sulfur times 1.25. That's and again, the looking at significant digits, 1, 2, 3. This is exact. It's exact. We don't need to consider it significant digits. So we want 3 here. So 40.0 grams of sulfur will make 100 grams of sulfur trioxide. You don't need to worry about the atomic numbers there. That won't. It's all cool. So I believe that answers our question. Okay, number 10. Number 10 says, to make 44.0 grams of carbon dioxide, you must combine 12.0 grams of carbon with 32.0 grams of oxygen. That gives us 44. Okay. Further, it says, if a chemist combines 120.0 grams of carbon with 160 grams of oxygen, how many grams of carbon dioxide will be made? If a substance is left over, indicate whether it is carbon or oxygen, and also determine how many grams are left over. Okay, if these proportions are the same, we can just add them up or multiply this by 10, but they're not the same. Okay, because 10 times 12 is 120, but 10 times 32 is twice this. This is only 5 times this number. So, therefore, we can see that only 5 times this number will be used of this substance. So, times 5 gives us 60 grams. So, it'll be 60 grams of carbon will interact with 160 grams of oxygen. And that will give us 220 grams of carbon dioxide. And these aren't units, so I'm not like adding these units or something. Okay, they're just, that's what I'm actually, those are the names of the substances of the word. Okay, so I will do that, right? So I would make 220 grams, 0.0 grams of carbon dioxide. And as we said, we'd only be using 60 grams of the carbon. So 60 grams would be left over, 60.0 grams of carbon, because our rules of precision apply with addition and subtraction. So when we subtract this, we get that. Okay. So 220.0 grams of carbon dioxide and 60.0 grams of carbon are left over. Number 11, you are told that a molecule contains a total of 17 atoms. If the formula is C5H10Cl(X), what must X be? So we're told that it contains 17 atoms. So 5 plus 10 plus X, 5 plus 10 plus X will equal 17. So 15 plus X equals 17. Obviously X is 2. So this will be 2. X is equal to 2. Okay, number 12. Which of the following atoms would be considered nonmetals? W, N, E, X, E, M, N, F, E, and S. All right, so you need to look these up. The best place to look them up is either the front of the book on the inside, front and back covers, where they have the periodic table and the list of the elements, and find where they are. This is tungsten here, it's number 74. And it is a metal, so it would not be considered a nonmetal. This is neon, it is number 10, and it would be considered a nonmetal. This is also right near neon, it's number 54, it's xenon, also a nonmetal. Okay, Mn, number 25. And if you find it there in the periodic table, you see that it's manganese. Not magnesium, manganese. It is a metal. There's not a nonmetal. Fe, number 26, right next to it, is iron. We all know that is a metal, so it is not a nonmetal. S is 16, sulfur. And it is a nonmetal. So of these 6 elements, neon, xenon, and sulfur are nonmetals. Okay, and the final, oops, dropped my eraser. The final question on the test is number 13. Which of the following compounds would conduct electricity when dissolved in water? Okay, there are 2 more questions. I forgot about them. Which of the following compounds would conduct electricity when dissolved in water? C3, H6, Cl, F. Na, NO3. C, S2, Ba, SO4. Okay. So what they're asking us is which of these are ionic compounds, and ionic compounds are going to contain a metal. So the first compound listed is carbon, hydrogen, chlorine, and fluorine, and they are all non-metals. So this will not conduct water. No, not conduct water. Conduct electricity. No. Okay, NaNO3. Now this is sodium, this is nitrogen, and this is oxygen. Sodium is a metal, so yes, this will conduct water. There I go again, conduct electricity. Here is carbon, and this is sulfur. Both of those are not metals. No, this will not conduct electricity. This is BaSO4. Ba is barium, sulfur, oxygen. This is a metal, therefore it is ionic, therefore it will conduct electricity when dissolved in water, yes. So of these 4 compounds, this one and this one, this happens to be sodium nitrate and barium sulfate. Okay, number 14, name the following compounds. A is Al2S3, B is SF2, C is C2F6, and D is BEF2. Okay, so first we need to identify whether these compounds are ionic or covalent, because that will help us to decide which nomenclature we're going to use. Okay, so A is ion. This is a metal, right? Aluminum, and this is sulfur. This is sulfur, and this is fluorine, right? This is carbon and fluorine, and this is beryllium and fluorine. Okay, so since these are both ionic, I'm just going to mark them that way. With ionic compounds, we do not use prefixes. With covalent compounds, we do. Okay, so here I'm not going to say dialuminum. I'm just going to say aluminum, and the sulfur I'm going to change to sulfide. So this becomes aluminum, unless you're British, and it's aluminium. Aluminum sulfide. Okay, this one is covalent, so I do need to use the prefixes. So here, this is just a mono, so I'm just going to say sulfur. I only use mono when it's not the first element being named. And here, this is fluorine, and it has two, so I'm going to say di. I'm going to change the ending to an ide, difluoride. Sulfur difluoride. Okay, here is another covalent compound with carbon and fluorine. So this is going to be using the nomenclature. Since this has two atoms, I'm going to use the di prefix here. So dicarbon. And now this one, I use the nomenclature for 6, which is hexa. And I change the ene to an ide, hexafluoride. Dicarbon hexafluoride. Okay, the final element in number 14 is an ionic. So we're going to not use the prefixes and just name this and then name this with an ide compound. So this is Be is beryllium and fluoride. Okay, and there is one more problem. What is the chemical formula of sulfur trioxide? Okay, so that tells me sulfur and oxygen are both not metals, so this is going to be a covalent compound. So sulfur, since there's no prefix before the sulfur, it's like letter B. In number 14, it tells me it's a single atom, and so it's going to be S. And the trioxide tells me that the oxygen is the second element. The oxide has been, the ending of the gin has been changed to ide, and it has 3, so it's SO3. Okay, and I hope this was helpful for all the answers to the test for Module 3. Let me know if you have any questions. Thank you.